So we are going to see what a thread is, and we will talk about the states of thread and priorities, and then we are going to spend some time how to create a thread class, and then we are going to actually spend a big chunk of our time for creating and running a thread. So basically how you can actually perform a particular chunk of task using a thread, and we'll talk about the thread group and synchronization, and how inter-thread, how two threads, or actually set of threads, can communicate each other, and then we will see how we can use timer and TimerTask classes. So what is a thread? So thread is basically a sequence. It represents the sequential flow of control of your program. Okay. So when you are starting your application, it's gonna be, your main method is actually being processed as a thread. Okay. The reason that concept of threads are important is because because in many cases you want to handle your task in parallel. So it's actually called concurrent operations. Okay. So in that case, what you want to do is that each operation is being handled by a separate thread in parallel. That will give you a much better performance. Okay. So sometimes we call it multi-threading application. Multi-threaded application, that means an application is being run with multiple threads. So each of those threads actually performing tasks in parallel. Okay. So yeah, so this is the example. On the left, you have an example of single thread case. Okay. So you have single thread is actually performing task. And now we have a multi-threaded application on the right, and here we have three threads performing tasks. So of course, multi-threaded applications are supposed to provide much better performance than sequential and single-thread based application. So multi-threading support in Java platform. So each application has at least one thread, or several if you count system threads. Okay, so we're going to actually see later on, even if you're running a very simple Hello World application, it has the application thread, and then it has several system threads. Okay, so in fact, it will run your application. In fact, involve multiple threads. Okay. But from developer programmers' point of view, you start with just one thread, which is actually a main thread, and that's the one that is running your main method. And later on, you can actually create other threads manually in your code. So those are the things that we are going to learn. How can I create other threads in my application so that I can give the chunk of a task to that particular thread, so that these threads are running in parallel. Okay, so thread state. So thread could be in one of these 5 states. Running is actually actively running, so it's in control of the CPU. Okay. Ready to run is, it can run, but it's not given a chance yet, so it doesn't have a CPU. Okay. Resumed is ready to run after being suspended or blocked. Okay. And then suspended, voluntarily allowed other threads to run. You can suspend yourself, meaning a thread can suspend itself, and then it becomes a suspended state. Blocked means the thread is not doing anything; it's waiting for something to happen. For example, some resource to be available or some event to occur, and things like that. Okay. Okay, then thread priorities. So there are, in fact, the 10 priorities in thread. Okay, so it ranges from 1 to 10. It represents, how urgent that thread is supposed to be run. Okay, so the higher number that priority has, it means it's more important than low priority, low numbered thread. Okay, let's say you have 2 threads are ready to run, and one has a priority of 5 and the other one has a priority 10. Then the one that has a priority 10 will be considered as a next thread to run. Okay. Okay, context switch. So context switch means that the thread snatches the control of the CPU from the another. So basically, CPU is running a thread. You can think of a CPU can run on a single thread. Okay, so even if the multiple threads are actually running in parallel, basically a single point in time, a single CPU can run a single thread. Okay, but these days we have what is called the multi-core or multi-processor machines, which means that those machines in fact have a multiple CPUs. Okay, so each of those CPUs can actually run different thread. Okay, so those are typical the architecture these days. Even your laptop in fact have a multiple CPUs. So it's very common to have a multiple CPUs. So in that case, each CPU will actually run each a thread. Okay. Now, suppose if you have a single CPU and the single CPU can run a thread a single point in time. Okay. So thread has to actually take turns. So those taking turns are called context switch. Okay. So this context switch could actually occur when running thread voluntarily relinquish CPU control, so by suspending himself. Okay, or running thread can be preempted by higher priority thread. So the machine will operating system will actually interrupt the existing running thread, and if there is in fact the higher priority thread waiting for the CPU to be available. Okay. Now, if there are more than one thread that has the same priority thread, then the operating system will determine which one to run next. I mean, it depends on operating system. Okay, so in the case of Windows, as a default, it uses a time-sliced round-robin scheme. Okay, so thread group. So thread group represent a set of threads. So the set of thread actually belongs to a thread group. Okay, so in fact, when you are running your Java application, you are going to see two thread groups. One is system group, and the other one is the application group. Okay, so this thread group form a tree in which each thread group except the initial thread group has a parent. So these thread groups could actually have hierarchical tree structure. Okay. And a thread is allowed to access information about its own thread group, but it's not allowed to access its parent thread group. So this is an example of thread group. So I could, so we can actually see how we can actually start a thread. So here you can actually create a brand new thread, and then you are starting that thread. Okay, so we are starting 3 thread. And then get the thread group of the current. You can find a thread is always belonging to a particular thread group. Okay, so you can call the current thread method of the thread class. So basically this is a static method of the thread class. So you find what is the current thread that is running, and then you can find out the thread group that it belongs to. Okay, and then and display the names of the threads in the current thread group, and then you can actually display all the threads in that thread group. Okay, so this is an application that find out what is the thread group your current thread is running, and then find out all the threads under that particular thread group. Okay, so exercise 1. By the way, I have actually modified the hands-on lab this morning. So if you have downloaded this hands-on lab yesterday, please re-download it. Okay, so let's take a look at the hands-on lab documentation thread. I actually switched. This is actually supposed to be thread group and thread priority. I didn't. Looks like I didn't make that change here. So exercise 1 is basically playing around with a thread group, and we want to see all the we want to see all the threads, and we want to see thread priority. Okay. So here we are creating 3 threads. Again, we are going to learn how we can create these threads later on in detail. So just for now, this is the way that you are going to start 3 threads in your application, in your main method. Okay. All right. So in my main method, I created 3 extra threads. So when you're actually running main method, that is running in a method. Okay. So by the time here, you are going to actually have 4 threads. One is main thread. that is started by the Java runtime, and then you created 3 more of your own. Okay, so here I created. Now I try to find the what is the current thread that is running, and then I want to get the thread group, and then I want to actually display all the threads in that particular group. Okay, so so yeah, this is the thread application. For now, don't worry about the logic here. We're going to actually learn this one in detail later on. And then you build and run the application. So when we run the application, so let's say run this application is a thread group test. So I'm going to run it, thread group test. Oops, this one, and I'm going to run it. So you can see there are 4 active threads in this thread group. So one is main. The other one is called Boston, New York, and Seoul. So those are the names I gave to the thread. Okay, all right. So that is basically how we can find out the thread group a particular thread belongs to. Okay, so that's the and 1.2 is display all thread in the system. So here I created my own thread, and you can actually call find all thread method in here. Basically, we get the current group. Yeah, so you can actually get the from the current group. You can call the get parent of that group. Okay, and then you want to actually display all the in this case, the parent group is supposed to be system. Okay, so system group will have other thread groups. So when you run the application, this is what you're going to see. So these are the system group. Okay, so the there is a 3 thread going on in system group, which is a reference handler, finalizer, and signal dispatcher. Then we have our 4 the threads in our main thread group. Okay. The last one is view all threads in the system using GUI. So in this application, we are going to display all the threads that are running. So that is view all threads. So let me run this application. Okay, so yeah, so these are all the threads that are running. So you can see we have the 2 thread group, a system thread group, and main thread group. And you can see in my application, in main group, we have a main method, and then we have a bunch of other threads like AWT. Those are all related to the GUI. So yeah, we're actually running GUI application. That's why it's actually running this AWT thread. Okay, and these are the priorities. Okay, so reference handler has a priority 10. And here Java 2D that has a priority, and rest of it is 5, 6, 8, and 7 or something like that. It's all alive, and thread name. Okay. All right. So I'm going to give you about the 7 minutes to try this. Yeah, actually 1.4. Yeah, we also have a 1.4. It's actually priority. Okay. So here we are actually starting this thread, giving a priority 10. Giving this thread as priority 5, and giving this thread a priority 1. Okay, and then in this code we are just kind of writing number. Okay, and then you can see the ones that has a priority 10 is actually running before the thread that are priority 5, and the one that has a priority 1 will actually run the last. Okay, so you might as well just run that application as well. Okay, so I'll give you about 7 or 8 minutes for this. Going to be okay. So next we are going to talk about thread class. Okay. So thread class has multiple constructors. So you can create a thread without passing anything. You can give a name to a thread, and then you can pass the runnable object and all that stuff. So don't worry about these constructors. We're going to actually see how we can use these things, and then it does have a constant the priority, max priority, mini priority, and non priority, and then it has the method such as current method. Yeah, so you can see this is a static method, right? So this is the one that we have used in exercise 1. and we can get the name, we can set the name of the thread, and we get the priority of that thread. We can see whether that's alive or not, meaning whether it is in fact running or not, and all that stuff. Okay. Now that's a thread class. Now let's see how we can create a thread. In fact, there are multiple ways. Okay. So you can actually see there are two ways of programming for creating Java thread. So the first way is extending thread class, and the other way is implementing runnable interface. Okay, so the reason you might have to choose second one is because in Java you can extend only one parent. So if you are trying to create a thread class that already has a parent, then you cannot extend thread class in option 1. So in that case, you can implement runnable interface. Okay, so we're going to actually take a look at both options in detail. Okay, so let's take a look at the first option, extending thread class. So this case, you are creating your class brand new, meaning your class does not extend any parent class. It doesn't have any parent class, so you should be able to extend thread class. So once your subclass extend thread class, then you have to actually provide run method implementation of the thread class. Okay, so the run method is like, is a main method of regular Java application. So in regular Java application, the way that you let the Java runtime, what logic is actually the logic inside a main method, right? For thread, the thing that you want to actually indicate that to be run is inside the run method. Okay. All right. So then the instance of that subclass will be created. Okay. So object will be instantiated, and then the thread and the start method of the object instance needs to start the execution. So it's not really, you don't actually, invoke the run method directly. You are going to call the start method of that object. And then start method will trigger the invocation of the run method of the object instance. So inside the run method, you actually have a task to be performed. But, in order to run the logic inside the run method, the start method has to be invoked. Okay, so let's see an example of this. Now, in this option, so basically we are looking at the extending thread class. Now there are two different programming models that you can choose in terms of where you want to actually call the start method. So scheme number 1 in this case is that start method is not in the constructor of the subclass. Then the start method has to be explicitly invoked after object of that class is created. Or scheme number 2 is that you could have the start method as part of the constructor of your subclass. In that case, the start method does not have to be explicitly invoked because it will be invoked as part of the constructor. Okay. Now you might want to say at this point, I am confused, and I perfectly understand. Okay. So let's see the code. So this is the scheme number 1. So this is the case that start method is not in the constructor of the subclass. So this first part of the code, I'm actually creating brand new thread class, subclass called the print name thread, and extends thread. Okay. So it does have a run. It does have to provide run method implementation. Okay. So basically, it just gets the name of the thread, and then it just print it out 100 times. That's what it does. Now, because the start method is not in the constructor of this print name thread case, this start method of this object has to be created. So in the main method, let's say we created an object instance of A, meaning we created this print name thread A, and then we have to call start method directly like this. Okay, and then we created another thread called the print name thread B, and then we have to call start. Okay, so as I said before, you cannot call run method directly on your object. You have to call start method, and this start method is the one that has to that will actually call run method eventually. And the reason is because the start method has to construct some kind of environment first, So that's the reason, you have to call start method, and start method will actually, construct some environment, and then it will call run method. Okay, so this is scheme number 1. Okay, scheme number 2, this is the case that I call the start method of inside the constructor of print name thread. In this case, all I have to do is just create the thread object. When I create the thread object, the constructor of this thread class, print name thread class, will be invoked, and inside the constructor it will call start method. So this is the case that you don't have to call start directly here because it gets created as part of the constructor invocation. Okay? Alright, so let me actually explain exercise 2, and then let's have lunch time. So this is the first case, is that the start method is not in the constructor of the subclass, and the second case is the start method is in the constructor of the subclass. Okay, so let's actually run extend thread class test 0, extend test class 0. Yeah, so this is the one. So we're gonna actually run it. So this is what you get. Okay, so let's take a look at the code. So again, this is the same code. Okay, so print name thread, extend thread. Okay, and it does provide run method implementation, and then in the main method we have to start. We have to call start of that object. Okay, if you don't call it, then the thread is not gonna get started. Okay, so you might want to actually comment this out and see what happens. Okay, so that is the case where you are starting manually. Okay, and here you are actually adding 2 more threads. Okay, you're actually creating another thread, and you're creating another thread, and each of those threads need to be started. Right? Okay. So that is the 2.1. 2.2, we are going to add start method inside the constructor of the subclass. Okay, so in this case, in your main method, all you have to do is basically creating an object of that thread class, the print name thread class, and then it should run. All 3 threads are supposed to be run. Okay, all right. So that is exercise 2. So I'm going to give you this 10 minutes, and we'll have a 30 minutes break. So we will be back 40 minutes after hour. So we'll be back 1:40 Boston time. Okay. Alright, so we have looked into the scheme where you are going to create a thread by subclassing thread. Okay. Now, the second scheme is implementing runnable interface. So runnable interface should be implemented by any class whose instances are intended to be executed as a thread. Okay, so the implementation that implements runnable interface should have a run method. Okay. All right. So why you want to actually create a thread using runnable interface? The reason that you have to use runnable interface is that some classes already has a parent class, which means that that class cannot extend thread class. Okay. So in that case, if you want to make that class to be executed as a thread, then you have to implement. That thread has to implement the runnable interface. Okay, so same ways as we have seen, you have 2 schemes. One is having the start method of the thread object needs to be explicitly invoked, or the start method is going to be in the constructor as well. Okay, so same deal. Okay, so let's see the first. So here we have a print name runnable subclass, and it already extends some class. So this class cannot extend thread class anymore. So I have to actually implement runnable interface. Okay, and then I can provide run method implementation. Okay, all right. Here, because this constructor class does not have start method, we are going to once we created this runnable type of thread object, then we have to manually start it. Okay, again, this is the same deal that we have seen. And the other case is that you are going to create a thread right here. So by passing this object and the name, and then you are going to start it. Okay, so in that case, you don't have to start manually in your code. Okay, so this is pretty much the same pattern that we have seen in previous case. So let's do exercise 3. Okay, so this one is, again, this is the pretty much the same code. Okay, so here we implement Runnable, and we implemented run method of this Runnable interface. And since we have not included starting thread code in the constructor, we have to start it ourselves. Okay, so you have so you create the print named Runnable object, and you have a runnable type. Then you are going to pass that runnable type to new thread. Yeah, so this is, you have to actually create a new thread object passing that runnable object, and then you can run the start. Okay, and the other one is you are going to create a thread object from this runnable, and then you're going to start as part of the constructor. In that case, you don't have to start yourself. Okay, so I'll give you guys about 7 minutes to finish this exercise. So between these two schemes, extending thread class versus implementing runnable interface, which one do you want to use? Unless you have a constraint of the class already has a parent, unless you have, if you have that constraint, then you got to use this runnable interface scheme. If other than that, either one is actually fine. Between the two, there is not much difference. Okay. All right, so moving forward. Synchronization. So let's talk about the race condition and how to solve it. Race conditions. Now, because we now have a multiple threads running at the same time, and they might in fact actually access the same object, same resources at the same time. So you might in fact have a race condition. Okay. So race conditions occur when multiple simultaneously running threads access the same object or same resource, and it might actually result in unexpected the consequences, okay, or undesirable consequences. So, for example, if multiple threads are trying to read and write to a file, depending on when those threads actually read and write, those the threads might actually see the undesirable the result. Okay, so we need to actually synchronize the behaviors of these threads when they access this shared resource. So let's see an example of unsynchronized example. So here, let's say we have a class called the toStrings, and it has a print statement. And this print statement is actually printing the first string and second string, and just kind of simulate, just to simulate long-running kind of task. We just kind of slip 500 seconds here, the 500 milliseconds here. And oops, sorry about that. Here, and then what we want to do is we are going to create we create a thread. Okay, yeah. So this is actually print string thread, and it's a runnable interface. And inside the run, what it does is it's going to call the print method of toStrings, passing this toString object. Okay, and inside the constructor is starting the thread. Okay, so in the main code, is basically running, is creating 3 threads, passing these toStrings. Hello there, and how are you, and thank you very much. Now, when you're running this application, because this print statement, this code is not synchronized, you are going to actually see this kind of mixed up result. Okay, so let's actually try to run that application. That is the 4.1. So that is synchronized example 0 unsynchronized. Yeah, so this is the one. So let's actually try to run this application. So you can see the things are really mixed up. How are, hello, thank you, there, and very much, and use. Obviously this is not what we want. What we want is that whenever this method is being invoked, I don't want any other thread to actually call this one. Meaning whenever a single thread is actually calling this print statement, I want other threads to be blocked so that the current thread finish. Okay, so that's what we want. So that's where we are, introducing what is called the synchronization scheme. Okay. All right. So synchronization log on Java. So Java offers what is called a synchronization monitor. You can think of it as a log. Okay. Java offers synchronization log, or we can call it just a log, on each instance of object class. So every single object in Java has this synchronization monitor, meaning every single object in Java can be a log. Okay? So threads are synchronized through object monitors, through the log, meaning when the particular log is used by one thread, and other threads cannot do anything, cannot actually access that code. Okay? That is the access that code that is associated with that log. Okay, so only the thread who owns that log, object monitor or object thread of the owner thread of the log or log, can execute the block of code that needs to be synchronized. And the code block, we are going to call it synchronized block. So a single thread can own the synchronized block as long as it has the object monitor. So once synchronized block code is finished, then object monitor, the lock, is going to be released. So any other thread waiting for that lock will be chosen. And one of the thread that is waiting for that lock will be chosen and will become the owner of the lock, and then that thread will actually execute the synchronized block to the end. Okay, so there are three different ways that you can synchronize using this log. Okay, meaning a thread becomes the owner of this log in one of the three ways. You can use a synchronized static method, you can use a synchronized instance method, and you can actually use a synchronized statement on a common object. So let's see each of these scheme. Option one is that if you happen to have a static method, and then you can use the synchronize like this. Okay, in this case, the actual log object is the class object. Okay, because this static method does not have an object instance of this class, right? So in this case, the class object itself is the log object. Okay, so again, so this code is gonna be owned by a single thread until until it is finished. So the result is going to be like this. Okay. Okay, so let's do exercise. So here's synchronized static method. So let's try to run it. Synchronize. Maybe this is the one. Okay, so it works as expected. Okay. And this is the one that okay, so yeah, so synchronized static. Okay, all right, I want to actually rename it. Okay, so let's go. The option two is this method could be non-static method. Okay, so in that case, the object itself, the object of this class object. So we have an instance object, right? So that object is going to be the log, the synchronization monitor. Okay, and the result is going to be the same. Okay, so that is this guy. Let's take a look at the two strings. In this case is instance method. Okay, so I'm going to actually change the name of this project. synchronized instance. And it should work. Okay, so as you can see, they work fine. Okay. All right. The last scheme is use synchronized statement on a common object. So in this case, we are not really using synchronized, desynchronized on this particular code block. Okay. Instead, what we're going to do is we are going to actually have a common object. So we're going to actually create two strings. So let's take a look at the main method first. We are going to actually create a common object, in this case 2 strings, okay? Then we are going to pass that common object for each of these threads. So for each of these threads, it will actually have, so these 2 strings object will be assigned to this, okay? So they actually have an access to this common object, and then inside the run, it will be synchronized on the common object. So which means this common object's log is used for synchronize this print statement. Okay? All right, so that is this one. This one, okay. So this is, I'm going to just rename it. Synchronized common object. Okay, so let's run this guy and should work fine. Okay, all right. So that is a synchronization. Okay, so I'm going to give you 5 minutes to try those exercises. Next topic is communication, inter-thread communication. So every object class, every object in Java is actually an object from object class. So object class has various inter-thread communication method: wait, notify, and notify all. Okay. So here the wait method is defined in the object class. So every Java class inherits this wait method. So wait method causes a thread to release the lock it is holding on an object, allowing other thread to run. So in our previous example, when things are actually being synchronized, inside, if you call wait, then you are basically releasing the lock. Okay. So wait can be invoked only within synchronized code. So in our code, so this is the synchronized code, right? So inside you can actually call wait. Okay, in that case you are releasing the lock. Okay, and any other thread that is actually waiting for that lock to be released will be notified. And it should always be wrapped in a try block as it throws IO exceptions. So wait could actually throw an IO exception, so you have to actually catch it with a try and catch. Okay. Wait can only be used by the thread that owns the lock on the object. This is always happening. So wait is going to be invoked only by the thread that owns the lock. Okay. Okay. So when wait is called, the thread becomes dormant until one of the 4 things occurs. So another thread invokes the notify method. So now when you call the wait, it becomes dormant, meaning it's actually waiting for the lock itself. Okay. So later on, when someone actually releases the lock, then this guy can have a chance to acquire that lock. Okay. So this notify and notify all is basically get called by the system when someone actually who owns the lock releases it. Okay. Another thread interrupts this thread. Another specify web time elapses. Okay. So when one of those occurs, the thread becomes re-available to the scheduler and competes for the lock on the object. And once it gains the lock of the object, then it resumes where it became dormant. Okay. Okay. So notify method so wakes up a single thread that is waiting on this object's monitor. So any thread waiting on this object, one of them is chosen to be awakened, and the choice is arbitrary and it occurs at the discretion of the implementation. Okay. So again, it could be used only within the synchronized code, and the awakened thread will not be able to proceed until the current thread relinquishes the lock on this object. Okay, yeah. So basically, when you call the notify method, it wakes up the another thread waiting on that particular object's lock. Notify all is waking up all threads that are waiting on the object monitor. Okay, and the highest priority thread will run first, of course. So in this example, I'm going to actually run the so let's actually run this inter-thread exercise together. Okay. So you're going to actually run the producer consumer unsynchronized first, and then we are going to run producer consumer synchronized. So what we want to write is that this is actually famous producer and consumer example. So producer is going to produce something, and then consumer will consume it. But consumer cannot produce, and consumer cannot consume until producer produces one, right? Okay, so consumer cannot consume until producer produces one. So what you want to do is the consumer wants to wait until produces one, and consumer wants to produce only after consumer consumes the previous one, meaning producer wants to produce only when there is a space to produce. So this is an example. Okay, so in this code, so let's actually run producer unsynchronized and producer synchronized. So let's run the producer unsynchronized. So let's run this guy. So what you are seeing here is that because the producer and consumer are not really synchronized, the producer produced one, but consumer just kind of asking, whether consumer just keep asking. So it's actually waste of the resources. And after consumer actually consumes, it just kind of exhausted this try, and then producers then started to produce. So this is not really right. What we want to do is we want the consumer and producer to sort of synchronize. So this is the example. So as you can see, producer produces, and then the consumer consumes it. Producer produces next one, then consumer consumes it. So what you want to do is, if you want this producer thread and consumer thread to sort of communicate each other so that they know when is the time to produce and when is the time to consume. Okay, so that is this logic. So basically we have this cubbyhole, and this is the cubbyhole that we want to the producer will produce in this hole. So in this hole you can have only one item. Okay, so producer wants to make sure there is a space, and before you produce, and consumer wants to make sure something is there, item is there before it wants to consume. So this is a case that so let's actually take a look at the nothing is synchronized. Okay, so this is unsynchronized case. So in this case we have a cubbyhole. Let's actually take a look at this code first. So we have produces the producer, and we have a consumer. Okay, and each one has this cubbyhole. This is a location where you want to produce and consume. And then we are studying these two threads. So producer thread and consumer thread now get started. Okay, now the cubbyhole is basically it's a place where it has a flag whether it's available or not, and then this content. Okay, so this is the sort of the back, something is going to be inserted into. And then this is a producer thread. So it extends a thread. Okay, and then it has to implement the run method, right? And it doesn't check, whether the somebody is not available, whether something is ready or not. It just keep putting it. Okay, same thing for consumer. Consumer just get it. It just keep getting it. It just try it like 10 times without any consideration of whether there is something to consume or not. Okay, meaning producer and consumer do not communicate at all here. Okay, so now we want to see, so that's the reason we're actually getting this undesirable result. Okay, now let's take a look at the synchronized case. So we studied producer thread and we studied consumer thread. Now we are going to have we are going to actually have this get method to be synchronized, and then we also have the put method to be synchronized. Okay, so here this is the get. This is going to be used by the consumer, right? So consumer will try to wait. So first of all, it checks whether there is actually something available or not. If it's not, it wants to wait. Okay, so it basically released the lock. Okay, now this is a put. Put is again, if it is something is already available, it wants to wait. Okay, so the in the case of put, it's waiting, and now if the consumer takes it out, right, the consumer is going to actually notify all, so it wakes up everyone. So at that point, when this thread is going to be awakened, so when this notify is being invoked by the consumer, then producer will actually wake here, and then will continue. So it will place the things into contents and set the flag to true. Then once it actually adds something into the bag, then it's going to notify all. So this is going to actually let the consumer to wake up, because consumer, when the available is false, is going to wait, right? So when this producer notify all after it place the item into this bag, then this consumer will wake up from this wait, and then it will take it, and then it's going to wake up producer. Okay, so that is the logic. Okay, so I'll give you guys 5 minutes to try this.